Now, rationals and radicals relate to exponents, as you're going to find out real shortly. I didn't hand out a colored piece of paper for you. I know that sometimes we fold paper. If you want to take your notes kind of in this sort of this organization, or if you don't, it doesn't really matter to me. It's your notes, but we're going to kind of have a category 1, a category 2, and then at the very bottom is kind of like one category. Again, you can kind of do the notes however you want, but there's going to sort of be 3 things that you sort of feel like that you're categorizing today. Okay, now, what are rationals and radicals? Well, we are referring to a certain type of exponent, specifically a rational exponent. That's kind of our first category officially, a rational exponent. That sounds like a lot of fun. Well, it is, because it's a fraction exponent. Fraction exponents take what we learned yesterday and sort of put their twist to it. Just a quick, by the way, you should have seen this in Algebra 2, but there's always that, maybe you didn't. I'm not going to kind of go over why, but some of you might feel like, yeah, I kind of recognize this a little bit. Again, it was an Algebra 2 idea, but let's make sure we understand it this year for sure. Now, there's going to be a couple rules kind of sprinkled in these sections. Here's your first one, and yes, copy it down, but do you understand what it's trying to say? You understand that it's trying to tell you if you have an exponent, that's a fraction. So I have an exponent of 1 over n. That's the same thing as a root. That's the same thing as what we technically call the nth root. Okay, now sometimes kids are kind of like, what do you mean root? Well, we all know about square roots. Okay, but there's other roots, which we've actually kind of dabbled with off and on this year, but we're going to kind of hit that a little harder right now. If you see 16 to the 1/4 power, 16 to the 1/4 power, maybe that's kind of strange looking, but that's called a rational exponent. And actually, it's referring to a root of 16. Now, we would call it the 4th root. It doesn't hurt to try to say it the right way. It's just the 4th root of 16. Now, what the heck does that mean? Well, honestly, that means you're trying to break down 16. And you're trying to break it down into 4 numbers. And oh, by the way, they have to be the same 4 numbers that would multiply to be 16. So you kind of do a little tabulating in your head. Remember, no calculator, at least eventually no calculator. And eventually you arrive at the number 2, because 2 times 2 times 2 times 2 is 16. So we call that the 4th root of 16. How about 196 to the 1/2 power? Okay, now the number's getting a little bigger, but first off, 196 to the 1/2 power is the same as the square root. Just a quick little side note. I know some people know this, but some people, maybe they didn't hear this. Yes, this is like the 2nd root, but we normally don't draw that little 2 because square root is the most popular one. But if you want to put it there, it's not wrong. Again, it's actually called the index or the root. Now, maybe you're like, should I know this? Well, I'll just say kind of nicely that it doesn't hurt if you're going to keep advancing in math to know your squares at least up to 200. What am I talking about, your squares? Well, I think we all know that 10 squared is 100. How about 11 squared? 121. Let's try 12 squared. 144, I hear it mumbling. So wait, 13 squared. 1, 6, 9. Again, as I said, it doesn't hurt to know these because it can make some things go a little more smoothly for kids. So wait, 13 squared, 1, 6, 14 squared. 196. 14 squared is 196. It doesn't hurt to know those up to 200. Now, if you don't know them, could you find them? I don't mean like on Google, but could you kind of figure it out? And if you're really on the ball or you're sort of bored over the summer, you can get your squares all the way up to 20 squared. So we left at 14. How about 15 squared? 2, 2, 5. 16 squared. 16 squared. Again, could you find it if you had to? It's 256. 16, no, I already did that. 17 squared. Now we start to get a little bit into the realm of I'm not sure, but it's 289. 18 squared. 18 squared is 324. 19 squared, we're getting close. 19 squared is 361. And then we get to 20 squared, which everyone says, no one says 400. Okay. Again, I'm going to at least require you to know comfortably up to 200, which we found out is 14 squared. So anyway, let's add to this rule. Basically, the rule now has an m over n. Jot it down, but notice what it's saying. It's saying the exponent is now m over n. Well, it's really the same thing that you just saw, except m is the power. M is the power. N is the root, which is still the case. Okay, now this just allows us to just pump up these examples a little bit, where now I can have maybe like 64 to the 2 over 3. 64 to the 2 over 3. Now, this will probably be the only time that I show this. It doesn't have to be the only time you show it, but just so you know, I might not write this step every time. But I'm talking about the root. Now, the root was, just like we did up above, is the denominator. So the root of 64, it's actually the third root of 64. However, we now have an exponent, we now have a power, I should say, of 2. Now what's happening here, kids, is you want to first do the root. You want to think about 3 numbers that give you 64. So just real seriously, you should be able to come up with 3 numbers that give you 64. And oh, by the way, they have to be the same 3 numbers. Okay, it's the number 4. Now it's just going to be squared. And so we end up with 4 squared, which of course is 16. But what happened here is that the denominator was the root, and then the numerator was the power. 9 to the negative 3 halves. It might be tempting to just punch that in a calculator, but you got to practice this. If you're still trying to figure out what's going on, you're going to see the same thing. Now, I know there's a negative, but I'm telling you, don't worry about it for a moment, because you still, and I'd say almost always, do the root. Here I'm choosing to show this just with an arrow. I'm going to skip writing it. I'm just going to say or ask, what's the root of 9? Now that's like the square root of 9. And of course that's the number 3. But I still have a negative exponent. So now I'm trying to figure out 3 to the negative 3. Well, from yesterday, that means that I want to write this as 1 over. I want to write it as 1 over. And of course the exponent becomes positive. So eventually we arrive at 1 over 27. Some kids also feel like they can skip this step. That is that you basically say, hey, negative exponent is going to become 1 over, get her done, and get right on to it. Try one. I showed you a couple. I know there's some varying levels of prior knowledge, but without me just telling you the answer, could you figure out 16 to the 3/4? 16 to the 3/4. Have you figured out that you want to do the root first. That's because when you do the root, the number gets smaller. So what's the 4th root of 16? Okay, we actually did it up here. So it's still going to be the number 2. And then 2 to the 3rd happens to be 8. People will ask, do I have to show any work? Well, I'll share with you that when you eventually get graded, you don't need to show any work. If you just write down the number 8 because you did it in your head, it's fine. If you just wrote down the number 8 because maybe you copied it from the answer key, that's not fine. Make sure that you know how to get it. Let me give you one more. We can kind of talk about this one together. It is slightly different. It's negative 16 to the 3/4. Negative 16 to the 3/4. How's that going for you? Finding 4 numbers that give you negative 16? Now, they got to be the same 4 numbers. It shouldn't be going very well. Okay, now, if it's not going well, that means that you have realized that you can't do an even root of a negative number. You can't do an even root of a negative number. Just like you can't do the square root of a negative number. You know, you get like imaginary numbers. In the same way, you really can't do an even for any negative number. All right. Onward and upward. We're going to now look at roots and radicals. Sometimes people start to feel like it's kind of the same thing, but I'm going to give it a different title, roots and radicals. But you're actually catching on if you feel like in the next few moments that this is kind of the same thing. Okay, everything today really kind of blends together. Before I give you like a little definition or a little idea, let me just give you a problem that's a radical. The one reason this is slightly different is because now I'm giving it to you as a radical. Okay, so we would say that's the square root of 25 to the 3rd times x squared. Now, if I give it to you as a radical, you could actually turn it back into an exponent. Why would you want to do that? Well, I'll show you. Okay, so we're going to take this square root, kind of change the color here. We're going to take the square root. We're going to change it back into an exponent. Watch carefully. It's going to have to be an exponent of 1 over 2. Okay, remember, a square root is the same as a 1 over 2. Now, why would I do that? Well, because from yesterday, we have some rules about exponents. And one of the rules says that you can bring in an exponent. Well, that's handy because I have some exponents there that I'm going to apply or bring in 1/2. Now, look, when you bring in the exponent, you have to understand that you're multiplying. And that would be like 3 times 1/2. 3 times 1/2 is going to just be 3/2. If I multiply the other exponent, it's going to be like 2 times 1/2. Well, maybe you already say that that's 1. I'm going to write it as 2 over 2, but you're right, it's just going to be 1. Look what happened here. I changed a square root into an exponent so that I could bring in the exponent. How do you bring it in? You just multiply it. Now, there's kind of no way around it. I still have to like figure out the root of 25. So I guess I'm looking for 2 numbers that give you 25. Of course, that's the number 5. That's still going to be to the 3rd power. X to the 2 over 2 is 1. And don't leave that 5 to the 3rd power sitting there. You might as well change that to 5 times 5 times 5, which is 125. I'm just going to write the answer over here to save some space. What you saw is not a bad idea, changing roots into exponents. It's kind of the little strategy. Okay, changing roots into exponents. Now, I'm not going to lie to you. This little strategy is meant for you to notice I don't really want to call it a shortcut, but to basically notice a pattern. So let's see if we can notice the pattern. Okay, now I've got the third root of 64 to the 1/2, x to the 6, y. Now listen, I could rewrite this, and maybe for some of us it's what you want to do. When I rewrite it, this 3 would really become a 1/3. You do have to kind of see that this is really a 1/3. What happens with a 1/3? What happens with a 1/2? Well, it's just going to multiply in, and look, it's just going to become the denominator. It's just going to become the denominator. Could I just make this 3 become the denominator like right now? Sure. Again, I could. Now, that would mean that this 3 is going to meet this 2 that's in the denominator, and you have to understand that they would multiply. So, of course, that's going to be 6, but they would multiply. What if I make it the denominator of this exponent? That's not that hard. That's just going to mean that I have 6/3. Now, the y, you do have to realize that the y, it does have an exponent, but if 3 is going to become the denominator, then it's 1/3. Now, honestly, what I just did right there is I kind of skipped a step. I skipped writing it as 1/. I just went right to it. Okay, roots are the same as denominators. Now, you still have to figure this out. You got to do the 6 through to 64. I'm trying to give you guys as many numbers to see as possible, because eventually you start to recognize some of these. What are 6 numbers that give you 64? Okay, well, if you investigate a little bit, you find out that 2 is your magic number. When I say if you investigate a little bit, basically a triplet of 2s gives you 8. Another triplet gives you 8, which is why 6 of them are going to give you 64. So I can do the root of 64. Now 6/3, just simplify it, x squared. Let's have a little talk about y to the 1/3. It's kind of a little bit of an oddball because it's like there's nothing you can do. Well, because there's nothing you can do, we're going to have to change it back to a radical. Now, what we really realize is that I basically wrote it the way that I started. Okay, if the problem started as a radical, then my answer will be as a radical. Okay, there was nothing you could simplify. I'm going to put a little star beside this one, just mainly to get your attention. It fits into this category, but you might argue that it requires a slightly different approach. This is the third root of 24x8. Okay, again, it's a little different approach, the third root of 24x8. If you're trying to find 3 numbers that give you 24, you're not going to find them. But inside of 24, there is a perfect number. Sometimes I just got to show you that you want to think of 24 as 8 times 3. Now let's sit on that for a second, because I don't want it to just be we got lucky. Why am I thinking of it as 8 times 3? Well, the honest answer is that 8 is a perfect root. Okay, or I should say it has a perfect root. Okay, 8 has a perfect root with 3. Okay, so I have to kind of see that number inside of 24. Now, the x, it's a little different because it's a variable with an exponent. So again, you just kind of have to see, and sometimes you just have to show you. You have to see x8 as x6 x squared. x6 x squared. Why? I don't mind telling you. It's honestly because 6 is the biggest number that's inside of 8 that has a perfect root. When I say it has a perfect root, it's just going to divide nicely with 3. But it is the biggest number. Both these circled numbers get their ticket to freedom. Their ticket to freedom is because they're perfect. Okay, so they get to be pulled out. Now, if I do the root of 8, I'm looking for 3 numbers that give you 8. You've seen that number a few times. It's the number 2. X6, it gets its ticket to freedom, but it gets its ticket by dividing with this 3. Dividing, so that gives you a square. Take a look at how the whole answer gets formatted. There's still 2 numbers left behind. Sorry, 3 and x squared. You're not perfect. You have to stay behind. I wish we had a little more time to let you guys kind of try another one of these, but I'm going to be honest, in the homework, and then we'll practice this a little more in class, but it's a little different type of problem. You're trying to pull out the perfect numbers. You'll see another one. But what I'd like to do with the time that we have is make sure that you see kind of this last section. This last section is really just a mixture. Just to be honest, I don't have like a title to give it, except that we're now just going to mix all the ideas together. Okay, now we want this to come out as a nice mixture. Sometimes you put a whole bunch of stuff together and put it in the blender and you don't really want to drink it. Let's mix these together and come out with something nice. Make sure that we're doing the problems correctly. Look what you got here. We got 2 to the 1/5, 2 to the 6/5. Okay. I can't really do the root of 2. Like, are there 5 numbers that multiply to be 2? Well, not that you should be able to know just without a calculator. So I can't really do that. So how about doing something with the overall exponents? If you see a fraction, that means subtraction. Okay, from yesterday, if you see a fraction, that means subtraction. Now look carefully what I'm doing. I'm subtracting the exponents. I'm subtracting the exponents, which quickly students realize, oh my gosh, I'm subtracting fractions. I wish I could use my calculator. Well, you're not going to have a calculator, but do you remember how to subtract fractions? You just subtract the numerator. So 1 minus 6 is -5. Keep the denominator. I'm not going to give you the hardest one to add or subtract, but it looks like you end up with -1. Not a bad little exponent. Are you ready? Here's like sort of a common mistake. You're close, but a common mistake is for kids to tell me that the answer is -1. Wait a minute. Why is that a mistake? I thought we got -1. But the mistake is if kids tell me that the answer is -1. What's -1? The exponent. Wait a minute. If there's an exponent, there has to be a base. There has to be a base. It's 2 to the -1. 2 to the -1. Now, if you agree with me that it's 2 to the -1, then we actually have more math that we can do, because we don't want our answer to have a negative exponent. No negative exponents. But it's a quick fix. Just flip it. Just flip it. Make it 1/2 to the +1, or just leave out the +1. They might need to sit on this for a second, okay? Because another mistake I see is that kids will cross out the 2's and still get -1. Okay, and if you're still saying, why can't you do that? Yesterday, I'm not sure anybody really blinked at this problem. Seriously, you didn't blink and you said x to the 4th. Did you cancel out the base? Did you like cross out the base? No, you made the base the same. You just combine the exponents. It's the same thing that happened over here. Keep the base the same, combine the exponents. Oh, I have maybe just a little word of wisdom here, which is basically yesterday's rule to add or subtract the exponents. You know, yesterday's rule, add or subtract the exponents, but as a little emphasis, keep the base the same. Keep the base the same. 64 to the 2/3, 64 to the 1/6. 64 to the 2/3, 64 to the 1/6. If you're a little bit daring, maybe you want to apply what I wrote up here. If you want to wait a second, I'm going to apply what I wrote up here. Okay, you should feel like there's something you can do with the exponents. It is Mr. Naylor's favorite property. You're going to add. You're going to add them. Now again, you're adding fractions. Yes, you are. You need to have a common denominator. You should feel like you can make this denominator the number 6 if you just multiply it by 2. That means the top has to get multiplied by 2. So we get 4, 6. But really, you add and now you have 5, 6. Okay, now remember, that's the exponent. So it's 64 to the 5, 6. Just because we've been talking about this, you should feel like that you're not done. Basically, you should, if you can, you should simplify. So I'm pretty sure there's 6 numbers that give you 64. It actually popped up over here. Or did it? Yeah, 6 numbers that give you 64. And then to the 5th power. If you're ready to do that in your head, you're doing 2 to the 5th power, which is why we end up with 32. Good. We have time for 1, maybe 2 problems, but definitely 1. This still kind of fits into this mixture category. Okay, we want this to taste good, so let's not put too much into the mixture. Let's make sure that we're just using the right rules. My wife likes to make some smoothies, and apparently if you put some spinach in there, suddenly it's really healthy, which is fine, but it also makes the whole thing green. So it still tastes good. Okay, really just the color of it, unless you like green. Now, if you don't like spinach, or if you don't want to mess up your smoothie, then don't do that. Remember, that's not property 3. It's so tempting though, but you can't bring an exponent in. Oh man, what am I going to do if I can't bring that exponent in? Well, I'm trying to get you to see here that you just do the math. What do you mean do the math? Well, in the parentheses, don't lose sight of the fact that you've got some numbers that you're adding. And 2 to the negative 2 is really just 1 over. Now, it would be a positive 2, right? But that's just going to be 1 over 4. We're kind of skipping to that. What I'm really trying to help you guys say is that we're just adding some numbers. Oh, you mean like 1/4 plus 3? Yeah, just add those together. Now, to add 1/4 plus 3, you do need a common denominator. But really, 3 is the same as 12 fourths, right? 3 is the same as 12 fourths. So, 1/4 and 12 fourths is 13 fourths. So I actually can do the math. I can add the numbers. And suddenly, it looks a lot more appealing to square 13 fourths. Okay, it's a nice smoothie. Yes, you can square, because we talked about the squares. So, of course, 13 squared is $1.69, and we know that 4 squared is 16. Ponder that problem just one more time. Notice that if it helps you, that we basically did the math, or a little more technical, we did the order of operations. You just want to make sure that you're not making up a rule. Okay, and really, I just have to follow the order of operations. Okay, I'm kind of looking at my notes here. There is another problem. I don't need to squeeze it in. Maybe we can talk about it next time, but there's a homework helper. As I kind of said at the beginning of the period, make sure you give yourself an opportunity to do these. Don't make the first time when it's graded All right, so take a look at that homework helper.